I think I'm the last one, the one last before final speaker. And I'm not really, I do not know natural farming very well, but I started to learn natural farming. And I would like to talk about natural farming in the view of plant pathology or plant disease. I made a title, Biological Control of the Soil-Borne Diseases and Natural Farming. Like previous speaker, Kim Kim told that he want to present next year after he completed many works. It was the same to me. I had maybe 2 or 4 slides of IMO study to understand the underlying mechanism of the natural farming in terms of the disease control. But Professor Kim skipped me pretty much, so I made the time and I made good former slides and added some slides. I may take maybe a little more time, maybe 5 in this case, not too much. So I would like to talk about this biological control and how it might be related to natural farming. And the biological control was become popular in 1980s in America. Before that, people used a lot of pesticides to control pest and plant disease, and it made a lot of environmental problems. As you know, DDT is one of the examples. So the nature Carson made the report, write a book, Silent Springs. So after congressmen or after American people read their books, they need to know that we have to control this pesticide. And then there was a famous scientist, James Cook. He was a USDA ARS research scientist. And they grew the wheat in America, northern area of America. They grow a lot of wheat. And wheat wheat has tapeworm disease, very severe. So the name of the disease is tapeworm. And then after they grow the wheat for 5 years, all of a sudden, this disease become less and less, and they want to know why it is that so. And they found out that there was due to the Pseudomonas species, which is a bacteria. So they call the disease conducive soil or disease suppressive soil, because there was that time that scientists tried to emphasize on that we have to do sustainable agriculture or integrated pest management. So now it becomes in Korea environmental friendly agriculture. Now I think it is now developed into the natural farming, I think so. So the biological control is accomplished through many ways. And first time they started with one specific organism like Pseudomonas gene, which control tapeworm disease. Gamenomyces gravis is the fungus name. And then they started, the bacteria, which is very, usually they talked about antifungal bacteria. So they could control plant disease. They look for this bacteria from rhizosphere soil or rhizosphere. And then they look for maybe not just bacteria, maybe fungi. So they looking for the Trichotoma species. This is very famous and developed as commercial biopesticide in worldwide. And another one, they looked there for Pythium oligandrum to control damping of plant disease. And also non-pathogenic Fusarium. Fusarium, you know, Fusarium wilt is a famous disease, and this non-pathogenic Fusarium study was large done in Japan specifically. So they used the non-pathogenic Fusarium species to control Fusarium wilt. And also they used this one to control nematode, not just the fungi, but nematode. So they call all these microparasites, and it was 1980s, all 1980s and 1990s. Then there's a famous scientist in Auburn University, Clapper. He suggested that there is a plant growth promotion rhizobacteria, which control plant disease, also promote the plant health, plant growth. Now we know that this bacteria can induce systemic resistance, make plant more strong to plant disease, like similar to the immune system in animal. And nowadays, now people is working endophytic bacteria, which reside inside of the plant, Then they fix nitrogen, not really much, not like nude nodulation nitrobacter, but they fix nitrogen, and they also produce oxygen, which is the plant hormone. So now after they started all this one, around that time people studied about organic management, which is compost, which might be very similar concept to natural farming. They file up all the plant residue and fermentate it and put into the soil, which there is a pathogen, plant disease, and the disease seems to be controlled, and not seems to be statistically significant. Scientists always make a statistical analysis, and then you see, is this significant or not? So they made all kinds of organic methods. The plant residue with the chicken litters and the cow dung compost, all sort of things. It's about biological control, and actually I do not have much slides, so I want to show what I have been through. Just some of slides to start specific disease. So this is the mechanism of the biological antibiotics. They produce antibiotics, and a site competition for the infection site. And Soil-Borne, the bacteria, they produce iron chelator, so plant pathogen cannot use iron. So plant pathogen does not grow very well. And nutrient competition and systemic induced risk, which I call, and I talked about this one already. And this one, this is a little bit out of this topic. A few years ago, I suggested some proposal to the government. And in Korea, there is a word for microorganisms, effective microorganisms. And I think this term was originated from Japan, and the Korean people try to use this effective microorganism. One of that example is yeast, they use a lot. So in this case, the Korean Agricultural Technology Center, many cities has all this fermentation facility. They grow these bacteria, and even for the cow, livestock, and they distribute to the farmer for free. So farmers can take this product without any money. They get this one and then spray to the crop field. So it's popular now. They use not only EM, which might be yeast, but that could be more than yeast, but the photosynthetic bacteria, maybe cyanobacteria, any kind of bacteria, all kind of or biological control agents, some bacteria, or the fungi. And this is my study. When I came here this university first time, I had to start something. And America, the producer rice somewhere, not every area, planting rice seed through the airplane. And Louisiana is one of that states. And in case of the Korea, the Hyundai Asan company, they have the big farm. They plant the rice seed through the airplane and grow the rice. In that case, seedling diseases occur often. And in case of the Korea, for not big farmers, if the farmer is too busy to do something, they plant rice seed just by air through the hand. And in certain cases, if weather is very cloudy, no seed emerges there at all. All these red color seed is there. And all those points is seed is there. So I started, maybe there might be some bacteria could control this kind of disease. And I would just give some of pathogen has very severe pathogenicity. And then at that time, this idea started that if I provide some nutrient for the bacteria, biological control agent bacteria, maybe it better control plant disease better. And it shows that all these this is bacteria biological control agent, and this is non-inoculated, and this one has inoculated one. But disease was not severe, but it was significant. And this is how I had some concept that this is bacteria. This is different carbon sources, and the bacteria use alanine very well and alagicus very well, but the fungus use this kind of proline carbon source very well, but they do not use sorbitol, galactose, or lactose. So I want to show that there is difference in terms of the carbon utilization between a fungi and a bacteria, and we added this concept to seed coating of the rice seed, and we had a good result. This is non-inoculated, so no PTO, and there's here is this is disease developed. The base means that there are some formulation, PTO and the fungus. But compared to this one, if we add mannitol or sorbitol, which bacteria, which fungus cannot use it, they control pretty well. And I will skip. We showed good result in seedling emergency and also in the field. The plot, which is square meters, it shows the good yield. And is in the paper, left one is controlled. The hypertrophic root rot is developed. They do not apply any bacterial suspension. And this one they apply bacteria and treat it and looks much healthy. And I added the same concept. Said Arabinosis bacteria is pretty well, but Hypothera capsule, which is pathogen of the Hypothera root rot of the pepper, does not use very well. So add those one, and this Hypothera capsule has a severe, there's a non-inoculatory control and no disease at all. Hypothera capsule, plant pathogen, only around 81%. All the plant got disease, about 80%. And if you add the bacteria, little controlled but still statistically significant, and if you add all those specific carbon sources, they control better. And this slide for understanding what happened after we inoculated bacteria and how the bacteria grows. And we made some bacteria which can fluoresce green color. So this is white type bacteria which does systemic diseases induces without no transformation that has green fluorescent bacteria. You do not see any green color, but under fluorescent microscope. But this is the mutant that has a green fluorescent gene. And if you grow rice seed in hydroponic cultures, and the bacteria goes inside, this is dynamic inside. And later on you lose a little bit, and 7 days, very less area, there's root care, those area. Okay, now I finished those one. Those slides was to development of the better biological control agent or understand of some mechanism, how the bacteria attach the rice seed or root very well, or how it goes, how it stays long. And now, just this year, I started to study on the indigenous microorganism in natural farming soil, which previous Professor Chun did study and project the farm. And I brought those soil, actually they brought that soil, and I studied the population of those ones. And I want to expect that maybe there are more bacteria, more diverse bacteria or more diverse fungal population in IMOs or natural farming soil. But I cannot make conclusion yet, but it was not really that I thought. Now, this is the word which you use often, IMO and EM or biological control. So I learned IMO 1, as you know. I asked this one often to the Professor Kim, what is IMO 1 and what is the indigenous microorganism? And when I talked with the Chris Trump, maybe there was a natural forest compost under the tree, because there is a natural population of the fungus and some bacteria too. So the IMO 1, you know, and IMO 2, you know, is an IMO 3 and IMO 4. And this soil must be originated from the Pacific farm, which they want to grow the crops. And I studied it. So this is for gram of soil, the colony forming unit, which is the number of the body of the bacteria or the fungi times 10 to the 5. And this is control soil. I think this is they grew the peanut. Jacques did study the peanut. And so control soil, natural farming soil, conventional soil, organic soil. There are a lot of bacteria in control soil. The more bacteria in natural or conventional or organic. We do not know exactly how it happened, and we are doing replicate again. We did replicate it, but my students and Professor Kim's students had different results. Why it is so, I have to check again whether it's reliable. Anyway, there are more bacteria, there are more fungi, and we cannot determine it. Not done when we do it. Anyway, number doesn't mean we're here. So maybe I thought natural farming soil has more number of the fungi. That's what I thought, because you add the rice bran and those ones. But maybe not. And this is a natural, again, I think second experiment. And we just focus on the fungi, natural soil, 18, organic, 13, and a conventional 7. So there is more fungi in natural soil in second experiment. But for this number, in case this 18 and 13, 18 times 10 to the 2, 18 times the 10 to the 2 in terms of the micro population, it may not be significantly statistically different, but we have to check again. But these slides say something about IMO things. This we studied IMO 1, IMO 2, and IMO 3, and IMO 4. This is maybe not really fresh, because IMO 1 we brought it and put in the refugee later. Maybe 2 weeks later we studied it. but IMO4 maybe maintain more freshness. But anyway, then IMO1 has a lot of bacteria. You see, 10 million times 151, so 10 million, maybe 15 billion, maybe billion of bacteria. And the fungi, 10 billion times 56, lot of fungi. And IMO2 is decreasing. And IMO3 is decreasing. IMO4, because we mix 1-to-1 ratio with the soil. So compared to this one is statistically much 100 times less, not 100 times, 10 times less. And this is about 10 times less too. So the population decreasing pretty much. So then I did not study yet the diversity of this diversity of the fungal population between two natural farming and natural farming soil and organic, the control soil and fungal population diversity between among the IMOs. Then there was some difference when compared to IMO1 to IMO4. When it goes this much, in this case, for fungi, we do not know about we cannot identify bacteria yet. So fungi, there are a lot of more spore-ready fungi, Aspergillus and maybe Tractor, but Aspergillus was dominant. This kind of color, there is Aspergillus, which have this spore-ratio. And then, when it goes to IMO4, which is this population, then there are more rhizophorus fungi. Rhizophorus fungi is zygomyces, which is called also dung fungi, and most of the rhizophorus fungi does not cause plant disease at all, but it grows so fast. It is similar to maybe one of the black fungi. Usually, the decayed by these rhizophorus. They grow much faster than this one, and they have black spores. It produces spore too, but maybe this one has more spore. It does not. The hyphae does not go faster than this one. This one is far faster than any other fungus. Fusarium go very slow. They grow slowly. So maybe the components of the fungal population might be changing from IMO1 to IMO4, and maybe natural farm soil may have different component of the fungal population compared to traditional compost, so organic amendment. This one we have to study. I cannot make any conclusion, not yet, but we have to study more and more. And this is a trichoderma. This one is also slower than rhizophorus anyway. This is a famous one, and many products now available for those ones. So I say, what is the difference between compost and compost, the organic amendment, or compost and natural farming thing? The source is different. The source comes from natural forest. So there may be mostly no pathogenic on the tree. But the organic amendment, they usually crop residue, which is leftover and mixed with all kinds of, if you add with the chicken litters and the cow dung, it will be all kinds of bacteria. So there might be different. And otherwise, later on, organic amendment, biological control maybe all work. Maybe if you use continuous, better, but those one cost money. But natural farming thing is your own natural, and it comes from natural forest compost. So that maybe makes difference, but we have to figure out that one later on, hopefully in your future. Okay, this is it.